Hi, in this video we are going to look at how we go about tackling exponential equations where two terms include a variable exponent. Now, the most important thing to keep in mind is the operation between the terms, as the operation will determine how we solve the equation. Let's look at an example. Here we have a multiplication sign. When multiplying terms, we can add exponents as long as the bases are the same. So we have a base of 3 and a base of 3. So we can say 3 to the power of x minus 1. Then we are multiplying by 3 to the power of x plus 2, which means we can add the exponents. Plus x plus 2 is equal to 27, which has a prime base of 3, and an exponent of 3. Now our bases are equal, which means our exponents will be equal too. So let's add like terms within our exponents. We have x plus x, which is 2x, negative 1 plus 2, which gives us positive 1, and we make this equal to the exponent of 3. Now we can solve for x. We have 2x over here, so let's leave it where it is. We're going to move 1 across. So we say 3 minus 1, which gives us 2. 2x divided by 2 gives us x, and 2 divided by 2 gives us 1. So this is our value of x. Let's do another example. When we have a plus or minus sign between the terms, we need to take the exponential out as a common factor. So here is our plus sign, and we have two separate terms. To take the exponential out, let's start by splitting our exponents. In the first term, we have 2 to the power of x multiplied by 2 to the power of 1. Then we have our plus sign. Our second term is 2 to the power of x, and this is equal to 12. Now we have 2 to the power of x over here and over here, and we can take it out as a common factor. So I can say 2 to the power of x, open a bracket. From the first term, I'm left with 2 to the power of 1, plus 2 to the power of x divided by 2 to the power of x leaves us with 1. Let's close our bracket, and we make this equal to 12. Now we've got 2 to the power of x outside of the bracket. Inside the bracket, we have 2 to the power of 1, which is simply 2. 2 plus 1 gives us 3. And we make this equal to 12. Now, to get 2 to the power of x by itself, let's divide both sides by the constant of 3. So we have 2 to the power of x is equal to 12 divided by 3, which is 4. Here we have a prime base of 2 with an exponent of x. 4 also has a prime base of 2 and an exponent of 2. Now our bases are the same, which means our exponents are equal. And we can see that x will be equal to 2. Please work through some exercises in this section before continuing with these videos.